Hey everybody, welcome back. Mr. Smith here. What we're going to do in today's deck is to show you a key skill. This is something that you're going to use in all of the pivot videos that we do going forward, and we're going to use it in class as well. The skill is how to get from a position versus time graph to a velocity versus time graph. So I'll dive in and point out one major reminder that we had taught when we talked about constant motion graphs. This is you moving in section A and then turning around and coming back. What do I notice? Here you're moving in the plus direction. Here you're moving in the minus direction. You're doing it in such a way that the slope here is steady. And because the slope of a position versus time graph is the velocity, what was going on here? Where you were moving with constant motion, a constant velocity. The velocity of this thing we could figure out from the slope, and it was nice and steady. So compare that to one where your motion wasn't so steady. What we've got here is something that looks a little bit like a parabola. So we're going to prove to you that the slope of this thing is changing over time in this slide deck, and then we're going to figure out what is that slope. To begin with, what I'm going to do is drop a tangent line. So that's a straight line that touches the curve at just one point. The slope of that tangent line is going to give us the velocity of the graph right at that moment. So you can see a little bit of a lazy slope here around t equals 1 second. We'll drop a tangent line a little bit later around t equals 4.5, 5 seconds. You can see the slope has really increased a lot. And then finally, out towards the end around 6 seconds, you can see the slope keeps right on increasing. So the graph gets steeper and steeper. The slope of this position graph keeps going up and up, and that means the velocity keeps going up and up. What are we going to do in this slide deck? We're going to show you how to get from this position graph that looks like a parabola to a velocity graph that looks like this. It's a diagonal line. Key transition. What you want to know is that the slope of a velocity graph is the acceleration of the object. So just like the rate that position was going up gave us the velocity, the rate at which the velocity goes up is going to give us the acceleration. So we'll jump into the example. What we did was we made some fake data, but it's pretty realistic. This is for a Kawasaki Ninja that's got a really strong acceleration. We tracked it for 4 seconds, plotted the positions. What you're going to do in this slide deck is to work with the graphical analysis to fill up this column over here so that you can make a graph of velocity versus time like we just looked at. So what I'm going to ask you to do right now is to pause the slide deck, open up graphical analysis, put these numbers in. This is going to be your X, this is going to be your Y, and we'll take it from there. Okay, welcome back. So what I want you to do is to notice we did everything that we should have done. We took the X and we made that into the time axis, and we took the position of the motorcycle and we made that into the Y. And so we've got our data in there, and you notice we've got a nice set of data points here. If I was in doubt, I would go down to this lower magnifying glass. If I wasn't sure that I was seeing all the data points, you press that and you see all the data points. And the first thing I want you to do with this is save a copy. So what we're going to do is to go up and click on that word untitled, and we're going to go save as, and we're going to give this guy a name. And so I'm going to call this the Ninja Acceleration or something like that. Ninja Excel, let's go like that. And we'll put it in a folder. Now I've got choices on mine. I've got all these different apps, but I'm sure you have the graphical analysis folder on yours. And so I would pick that one. And now I've got it saved, so I can call this data back up. That's really important because we're going to work with these in class. So what I want you to notice, 3 things we're going to do. First of all, this is not linear data. If I go and fit it with a curve fit that's a line, that's a pretty crummy fit, right? I get a line that gives me the average velocity. I'll drag that out of the way. The average velocity of the object over time. So that slant right there, the slope of that gives me the average velocity. What I notice is that if I apply a better curve fit, and what I'm going to do, we're going to use quadratic. And I'm going to get rid of the linear one. Actually, let's get rid of them both because I should have gotten rid of the first one there. Apply a curve fit. Let's make it quadratic. What you're going to notice is that the slope of this does exactly what we talked about. This graph matches all the points, so it's got a really, really nice fit to the points we were looking at. But down low, you can see down in this region down here, near 0.5 and 1 seconds, pretty flat slope. In the middle, around 2.5 seconds, kind of an in-between sort of slope, and the slope keeps getting steeper and steeper. So there's a feature I want you to look at. It's called tangent to the curve. The tangent gives us the slope of a small piece of the graph. So I'm going to go into my options. So I click the little curve fitty thing. And up in the upper part of this, I see tangent, and I'm going to turn that on. And now, if I go and tap right on one of the data points, you're going to see that I get a draggable line that shows me exactly what we were talking about, and which is the fact that at each point where we looked at the motorcycle's position, the slope of this graph was changing. And that is exactly what we were talking about. So the slope gets steeper and steeper, and that proves that this motorcycle is going faster and faster as time goes by. So how do we now take that idea and make a velocity versus time graph out of it and get all that velocity info we talked about? I'll show you right now. I'm going to go and turn off the tangent. And what I'm going to do is one final skill that's very important. I'm going to go up next to my position. I'm going to touch the 3 dots next to position. And this time what I'm going to do is I'm going to add a calculated column. So I press add calculated column, and we're going to call it velocity. So if you want to pause this and do exactly what I'm doing, then you're going to be able to finish this right along with me. So I've got velocity in meters per second. I'm going to say OK to that. It's going to ask me now to insert an expression. So I go and click on the insert expression button. Here's what you do. To get from position data to velocity data, we're going to use a thing called the derivative. The derivative is calculus, and that's over our heads right now mathematically, but the first derivative is going to give us the slope of our position graph at every single point. So what it does is it gives us what the tangent just gave us at every single point, and it's going to generate the velocity of the motorcycle at every moment. Now, to be honest with you, the way that graphical analysis works isn't going to do this perfectly, because graphical analysis is looking for big bunches of data, and we only have like 12 or 10 data points maybe here in our data set. So it's going to get a little wonky around the edges, but it's fine. For all the work that we're going to do this year, this technique is going to work great. And then when you guys move into higher math and you look at derivatives, this is going to really help you. So it makes sense. So we're going to click first derivative, position, comma, time. And you notice what happens as I've got a new column full of numbers over here on the right, which gives me the velocity of the motorcycle. What am I going to do with that? Final technique. Go over to where this says position, click on that word position, and you notice I now have a new option. So I can turn off position, and my line goes away. I can turn on velocity, and look what happens. I get a bunch of points that look like they fall in a pretty straight line. The fact that they're not perfectly straight is graphical analysis not being perfect at doing this with our small set of data. It's not going to bother us. We're going to click apply a curve fit, make it be linear, say OK, and now what we've done is we've made a velocity versus time graph. We can get the slope of that velocity versus time graph, and if you've been playing along with the game, you know what that means. We just got the acceleration of this motorcycle. Acceleration is 10.2 meters per second. What I just showed you is all the techniques on graphical analysis you're going to need to really kick some butt with the pivot labs that we're going to do going forward, and also some of the in-class stuff that we're going to do where we work with position data and turn it into velocity. Okay, thanks for watching. Keep up the good work. Have a nice day, and bring your questions to class. Bye-bye now.